So we have our last question, question number 7. Explain the following. So the first is Chomsky hierarchy. The Chomsky hierarchy is a classification of a formal grammars which are systems that generates a string of symbols according to certain rules. There are four levels in the Chomsky hierarchy, each representing a different type of grammar. So the first is type 0, which is known as unrestricted grammar, also known as recursively enumerable languages. These grammars have no restrictions on their production rules and can generate any recursive enumerable language. Type 1 is context sensitive grammar. Production rules are applied based on the context of the symbols. Type 2 is context free grammar. Production rules are applied regardless of the context, meaning the left hand side of the production rule can always be replaced by the right hand side. Type 3 is regular grammar, the simplest type of grammar with limited expressive power, characterized by the production rules of the form A arrow AB, where A and B are non-terminal symbols and A is the terminal symbol. So we have to now explain PDA, 2PDA and NPDA. So PDA stands for push down automation. A PDA is a type of automation which is a mathematical model of computation. It extends the capabilities of finite automation by adding a stack, following it to recognize context-free languages. So 2TPDA stands for two-way push-down automation. So a variation of it is the variation of PDA where the input tape head can move in both directions, not restricted to moving only to the right. So the NPDA stands for non-deterministic push-down automation, a PDA where there can be multiple possible transitions from a state for a given input symbol and stack symbol combination. NPDA is a powerful model that deterministic PDAs and they recognize the same class of languages. So now we have the recursive enumerable languages. So recursive enumerable languages, also known as recursively enumerable sets, are the languages that can be recognized by a Turing machine. A language L is a recursively enumerable if there exists a Turing machine that accepts every string in language, either rejects or loops indefinitely on string not in language. These languages are at the top level of the Chomsky hierarchy, which are the type 0 grammars. They are not necessarily decidable, meaning there might not an algorithm to determine the membership in the language of that always holds for any input. So, thank you.